This month's synoptic chemistry focus is a little bit on green chemistry, and this video is about greenhouse gases, really about how we can be very precise about our explanation of the greenhouse effect and link it to the properties of the gases that are involved. So, what are greenhouse gases? They are molecules which strongly absorb infrared radiation. So, different covalent bonds absorb different frequencies of infrared radiation, which you'll know if you've studied any infrared spectroscopy as part of your A-level. You will know, therefore, that the bonds that absorb infrared really well, that you can spot on an infrared spectrum, include the CH bond, the C double bond O, and the OH bond. So we can link that to realizing that the common molecules, carbon dioxide, methane, and water vapor, are all good or effective absorbers of infrared, so they're all greenhouse gases. However, when we're talking about global warming and climate change, we don't normally talk about water vapor being a significant problem in the atmosphere. That's because the concentration of water vapor, as it increases in the atmosphere, the water's just going to condense and turn back into liquid water droplets in clouds or fog, because it's got a much higher boiling point than methane and carbon dioxide. So it doesn't really matter how much water goes into the atmosphere. It's actually going to remain relatively constant. There's going to be an equilibrium between water vapor and between liquid water droplets. So it's not going to increase the overall absorption of infrared radiation. So greenhouse gases are vitally important in regulating the temperature on Earth. And you may have heard some fairly vague descriptions. You may have written some kind of vague descriptions about greenhouse gases trapping heat like some sort of foil blanket around the planet. Well, that's not very scientific. It's not really going to do for A-level. So let's explain what's happening a bit more clearly, and we're not going to use anything more than fairly basic GCSE physics ideas. So most of the radiation that's emitted from the sun is the form of UV or visible light. A lot of UV gets absorbed in the upper atmosphere by the ozone layer, which I'm going to talk about in my next video. But what that means is that most of the radiation that's reaching the Earth that passes through the atmosphere is going to be in the form of visible light from the sun. Visible light is going to get absorbed by the Earth's surface. And just like anything else that absorbs light, this is going to cause the Earth's surface to heat up. Now, if something gets warmer, it's going to emit more infrared radiation, which is what we mean when we talk about heat in terms of trapping heat. So, if there were no greenhouse gases at all, that infrared radiation would be emitted and it would travel straight back out of the atmosphere, because we know that infrared is a form of light and that all light travels in straight lines, so it would just go straight upwards. However, what we have instead is this layer of greenhouse gases quite low down in the atmosphere. And these molecules are moving around randomly as gas molecules do. So those molecules are going to absorb the infrared. They don't hold on to it. That's not what molecules do. They will move faster and therefore they will re-emit that infrared radiation. So the bonds are going to absorb it, but then we're going to re-emit it. But because of the random movement, when we re-emit that infrared, it doesn't all go straight back out into space. Quite a lot of the infrared will be re-emitted back towards the Earth. Sometimes we're a little bit lazy and we talk about the gases reflecting infrared back to the Earth, but that's not really true, because the infrared, some of it can pass through. If it was all reflected back, the temperature would rise extremely fast. So it's this emission, this re-emission after absorption, because it's re-emitted in random directions, a lot of that radiation ends up trapped, if you like, or coming back into that level of the atmosphere. So that's really important because without the greenhouse effect, the Earth would be too cold to support life. But the problem is that human activities over the last 2 centuries, basically mostly burning of fossil fuels, have dramatically increased the concentration of greenhouse gases, especially CO2, because that's what we're getting from burning fossil fuels, but we're also increasing methane, and methane comes from particular farming practices, particularly cattle farming, rice farming, and methane also comes from our landfill by anaerobic kind of breakdown of the stuff that we're putting into landfill. So an increase in greenhouse gas concentration has led to a corresponding increase in this average temperature of the Earth, which is what we call global warming. Now remember that this is an average increase, so it takes into account seasonal variations, geographic differences at the poles and the equator, and also just the differences between different years or decades. So this is real long-term data that we've been looking at. And this is what we can call the exacerbated greenhouse effect, because it's a much stronger greenhouse effect because of the increased amount of carbon dioxide. And because of sort of unpredictable weather patterns, we tended to, in the more recent years, moved away from the phrase global warming and towards the phrase climate change, as it's a more accurate summary of what is going to happen. So we should know some impacts of climate change, of course, really very varied and very wide-ranging, but particularly includes melting of ice caps, which leads to rising sea levels, flooding of coastal regions. You've then got a lot more extreme weather events. So that can be droughts, but can also be increased rain leading to more hurricanes, more monsoons. And that can also lead to flooding, particularly localised flash flooding, which we've seen a lot of in recent years. And of course, because of the increase in temperatures globally, we're going to get changes to habitats. So we're going to get extinction of particular species, or maybe species being confined to a much smaller region because there's only certain areas where the temperatures are correct for them to now survive. This particularly affects plants, and of course that means that it can affect crops and food production. So we might also get asked questions about the impact of chemical processes on the environment. And it's important to be specific if we're talking about greenhouse gases and climate change. We don't want any waffly stuff about, less harmful gases, or, not very specific ways in which chemical industry and chemical reactions and the way that we do them links to the greenhouse effect and climate change. So the main source of CO2 comes from burning fossil fuels. We do this to release energy. So anything that chemists can do to either find other ways to release energy or limit the amount of energy required for particular processes can be potentially more sustainable and have less impact on the climate. So some specific ways that chemistry links to that will be catalysts. So catalysts allow us to carry out reactions at lower temperatures and pressures because they're going to make the reaction faster. So we don't need to use other conditions. And high temperatures and high pressure always require energy, and energy usually comes from fossil fuels. We can also talk about recycling. So particularly materials like aluminium recycling uses only 5% of the energy as extracting aluminium from its ore, which you may remember requires electrolysis, a vast amount of energy to melt that compound, and also a lot of electricity, which is normally from fossil fuels. Other recycling also tends to reduce our energy costs, but not as much. We've also got the idea of chemists can be working on alternative fuels such as biofuels. So biofuels come from living plants which take in carbon dioxide as they grow and therefore have lower net carbon emissions. They're not really zero because they still require a lot of tractors to plant them. They still require transportation, they require separation, harvesting, all of that stuff. So they're still releasing greenhouse gases in that stage. And hydrogen, if we get hydrogen from a clean source, such as using solar power to electrolyse water, then that also has lower carbon emissions. And the other thing is that many scientists and chemists are working towards carbon capture and storage technology, which is using various different chemical reactions and other methods in order to actually take carbon dioxide out at the source, for example, in fossil fuel plants, and even to take it out of the air itself.